Hi guys, today we'll use data science to select a cryptocurrency portfolio. We'll employ network analysis techniques to try to figure out the top and the least influencing cryptocurrencies in the market. Using the power of Python scripts embedded in Power BI, we will analyze the performance of the cryptocurrency market over the previous years to generate the desired results. Link to Power BI file with the Python scripts will be available for you to download in a link in the description. The method we'll be using today is based on a research paper. If you're interested in understanding the theory behind it, you'll find a link to this paper in the description too. Before we start, make sure to subscribe to this channel to stay updated with amazing business intelligence and data science projects. Word of caution, this channel is all about data science and business intelligence projects. It's not about financial consulting, so make sure to make your own research before you do any investments. Now, grab a cup of coffee, sit back and watch. Okay guys, as a start, we want to collect some historical data for the cryptocurrencies. And to do this, we're gonna use this dataset from kaggle.com. As you can see, this dataset contains data since January 2015, and the price was taken at 12 a.m. So let's download this dataset. So this is the folder we downloaded. You can find historical prices for 50 different cryptocurrencies. Let's open one of them, for example, Binance. You will find it contains a date column, which contains both the time and the date and the price in US dollars. And those are the two columns we care about for this study. So now we have our data ready. As I said in the introduction, we'll do networks analysis for the downloaded cryptocurrencies. And we'll do it using a Python script embedded in Power BI. But before we embed a Python script in Power BI, there are a few steps we need to do. First, we need to download Python and we need to link it to Power BI. But first, let's go through the Python script prepared for this study, just to understand the intuition behind it. So I have the code here prepared in Google Colab. The first thing this code does is reading the dataset, and then it calculates the log returns and it calculates the correlation. And here there is one important thing to understand. As I said earlier, this analysis is based on a research paper. So this is the research paper, and if you go through this paper, it was performed on stocks, not on cryptocurrencies. And it carries one important assumption, that the stock returns are based on a normal distribution, which means we can use the log returns. With the cryptocurrencies, we need to be cautious about this assumption for two main reasons. Reason one, there is not enough historical data for cryptocurrencies. The normal distribution for cryptocurrency is still not fully confirmed. The second reason is the cryptocurrency market is more volatile than the stock market. So just keep this in mind while we are doing this study. The next part of the code, we calculate the network. The first line calculates the full network, and the second line simplify the network by removing the unnecessary links. And to calculate the network, we will use networks library. So this is the library here, it's called networks, and we import it as an X. Let me first show you how this network looks like. I already have it prepared here. So this is the network created. It shows all the cryptocurrencies as vertices, and they're connected through edges. Now if you go back to the code, we can see here we first calculated and then we calculate a simplified version. This simplified version will remove all the extra edges and keep the important ones, and it does it automatically using the networks library. Let me show you how it looks like after simplifying. So this is the network looks like after simplifying. You can see all the extra edges and important edges are removed, and it creates a filtered version of the network. Let's go back to the code. The next part here, we calculate the degree centrality and the betweenness. If you want to understand more about them, you can go through the paper. It's shared in the description. However, the centrality measure trying to find the central coins that influence the other coins, and by eyeballing this graph, we can see here we have Litecoin and Ethereum. Let's go back to the code. In the next part of this code, it calculates some other distance criteria, and after that it stores all the criteria calculated above in one single data frame. Finally, based on the calculated distances, we can calculate the central portfolio based on the average centrality. So we find the top 3 cryptocurrencies with highest average centrality, and also calculating the peripheral portfolio based on the average distance. And the average distance measures how far is the cryptocurrency from the central of the network. So if we look back at the network, we can see that we have some cryptocurrencies that are far away from the center. So those are the cryptocurrencies calculated for the peripheral portfolio. So this is the code. We'll do a couple of changes and we'll be able to embed it in Power BI. Now it's time to embed the Python script in Power BI. You can embed a Python script in Power BI in 2 ways. First, through the visuals here, and this you'll use it if the output of your script is a visual, like for example a line chart. And the other way is through Power Query. And this is what we're interested in today. So let's go to transform data. And if you go to transform tab, you can see here option to run Python script. And this script can be added as a step to a query. And in a minute, I'll show you how it's gonna be done. But before we do that, we need to install and set up Python. In previous projects, we have covered how to download and install Python. However, we'll go through it quickly here. So from Python downloads, we'll find a download button to download the latest Python. So click here, and once downloaded, double click on it, and it will take you through the setup. And since I have it already installed, it gives me the upgrade option. But for you, just select the default setup settings and install it. Now after having Python installed to your machine, there are few libraries we need to install. So let's go to the start menu, open CMD, and start feeding the commands to install those libraries. I have the libraries listed in a text file here for you. You will find it in the description. So these are the 3 libraries we will need today. Actually for us, we'll need those 2 libraries, and for Python to work with Power BI, we need to install also this library. All you need to do is copy this command and paste it in the CMD, hit enter, and it will go through the installation process. Since I have those libraries already installed, it gives me a message that requirements already satisfied. But for you, it will go through the installation process. And you need to do the same thing for the other 2 libraries. And now we're ready to move to Power BI. Now all we need to do in Power BI is to link Python to Power BI. So from File, we go to Options and Settings, Options, and we can see here from the list we have Python scripting. Let's click on it, and we need to give Power BI the location of the installed Python. It usually detects it automatically, but if you can't find it in the list, you can also select other. You need to navigate to the location you installed Python in. Now let's go back and select the link it's already detected. And that's it. Power BI now can see Python. Now we're ready to embed the script. Now in Power BI, let's start by get data, more, and select folder. And provide the folder path containing all the CSV files with the cryptocurrencies prices. So I have the path here, click OK. So here it loads all the files. Let's go to transform data, and it provides us with all the CSV files. Or what we care about is the content column, so let's right click and remove other columns. Now let's expand this and click OK. So we have one query containing all the coins, if you see here, you load more, you'll find all the 50 coins loaded. Now there is one issue with the date column here. If you remember when we saw one of the CSV files, some of them will have date format and some of them will have date and time. So to avoid errors, we need to remove the time from the date column. To do this, from the change type step, which is an automatically generated step, let's select the date type conversion and remove it. We need first to fix this column before we convert it to date. Now we have it in the text format. Now right click on this column and go to split column by delimiter. And the delimiter is basically a space between the date and time. Let's just put a space there and click OK. So you can see we have date 1 and date 2. If you look through this list, you will find all the time segments are listed for the files containing time. So we don't need this. Let's right click and remove it. Let's rename this to date. And we can see that there is an automated step generated to convert this to date. Now let's load this query and see how it looks like. Close and apply. So if we add a matrix here, just to see how the data looks like, let's feed to it the coin name, have it in the columns, and the date, and finally the price. The reason I downloaded the query and created this matrix just to show you that we have a lot of missing data. And even if you expand the year 2018, for example, you'll find some missing quarters. For example, this here, it has 2 missing quarters, and so on. So the idea is, when we want to use this data for the Python script, we need to make sure we have continuous data for all the cryptocurrencies. So from the list here, because before 2018 we don't have much data, we'll filter our data just to look at values from quarter 3 2018, and inside Python we'll drop the coins that don't have continuous values for the afterward years. So now let's delete this matrix and go back to transform data and work in our query. So as I said, we're gonna filter this. For date filter, we'll select between, and we'll select is after or equal to, starting from the year 2018, month July, 1st of July, so the start of quarter 2. Also, we'll filter the data to ignore the values after 2022, because we're gonna use 2023 data for the next part of the project. So we'll select here is before or equal to. Let's go back 1 year and go back all the way to December 2022 31st. So we have the data between quarter 2 2018 and end of 2022, which gives us 4.5 years. Let's click OK. One step here we can do is just to make the first letter of the coin name capital by right click on this column and go to transform, capitalize each word. That will make the first letter of each word of the name capital. Now in the next step, we'll just reference this query, right click and select reference. Let's name it network analysis. Now we just delete the total volume and the market cap. We don't need those 2 columns. Next we select coin name, and from transform we select pivot column. Let's select value column to be price, and from advanced option, let's select don't aggregate. Click OK. We're just preparing the data to enter Python, and Python script expect each of the cryptocurrencies to be in a separate column. So now we have it in separate columns. And one more step we need to do before we add the Python script is to convert the date to text, because Python can't recognize the Power BI date type. To do this, we select the date, right click, and change type and make it text. Now we're ready for the Python step, and we will add the Python as a step in this query. Just click on run Python script, and we need to add the code here, and I have it ready, the same code we discussed earlier in this video. So let's just paste it here. There is one important thing here. Power BI treats the previous step name as dataset, so this name is already reserved for the previous step data, so we need to update our code to take the previous data as the name dataset. So now click OK. Once we click OK, we can see this error. This error comes from Power BI because we're trying to reference query data from previous step inside Python script. As a workaround to overcome this error, you just need to do the following. Go to File, and from Options and Settings, select Options, and from Current File, select Privacy and switch to this option. Ignore the privacy levels. Click OK, and from Home, click Refresh Preview. And here we go, we have the output of the script is listed here. If you remember, we said that Python will drop all the non-continuous coins. So let's see what's left. If you click on table here, we can see that we have fewer coins left with continuous data. To be exact, we have 16 coin left. So we're doing the analysis for 16 coin. And because we have only 16 cryptocurrencies, we made each portfolio to read only 3 values. Now for the next step, let's reference the network analysis again and name it portfolio. Here we are only interested in the portfolios, so let's just filter for central portfolio and peripheral portfolio. Click OK. Now from value, let's expand this. Select only the crypto column and click OK. So now you can see we have 3 cryptos in the central portfolio: Ethereum, Litecoin and Cardano. And in the peripheral portfolio we have 3: Ethereum Classic and Ripple and Tron. Of course here Ripple is the same as XRP. One thing very interesting I noticed here, that Bitcoin is not part of the central portfolio. So based on the network analysis method we used here, for the previous 5 years or so, Bitcoin is not influencing the market as it used to be. At least this is what the data says. So moving forward, we need to get the values for those cryptocurrencies. To do this, we'll go to merge query. The first query will be the portfolio, and the second query will be the crypto prices. So we're gonna link it based on the crypto with the coin name. And we'll use left outer. That means we need all the cryptos from the first list matching the ones from the second list or the second query. Let's click OK. Now let's expand this and just select the date and the price. Click OK, and we have the prices for both of the portfolios. Now we have our data ready. Now let's just create one more table for dates. Let's reference the portfolio, name it date. So we only want to keep the date column. Let's remove other columns. Now let's remove the duplicates. From home we can remove rows, remove duplicates. Now we have the date table ready. Let's just disable the load for the crypto prices and for the network analysis. So we only want to load the portfolio and date. So now we have the data transformation complete. Let's close and apply. Now we want to visualize the portfolio's performance over the 4.5 years we did the analysis for. So as a start, we want to create a measure to calculate the percentage change. To do this, we'll go to portfolio, right click, new measure. I have the measure ready, I'll just paste it. So this measure will start by calculating the start period and calculate the price at the start period, and then calculates the end period price, and then calculates the percentage. So let's click commit and convert it to percentage. Next we'll add a line chart and feed to it in the x-axis the date. Let's remove the hierarchy. Just click here and select date. Next we'll feed in the percentage change to the y-axis, and finally we'll use the name, which is the portfolio name, in the legends. Now let's format this a little bit. From x-axis let's remove the title. Let's add a zoom slicer only for the x-axis. Let's change the line colors to make it clear. For the peripheral, we'll use this color, for example. And from general, we do the usual formatting, remove the background, add borders with rounded corners, thin, and add shadows. Also, we changed the title, price change by date, and portfolio. Let's put it in the center, change the text color and the background color. So now let's have a closer look to comparison between the two portfolios. We can see that the central portfolio is doing better. Let's zoom in to periods. We can see here 2018 there is no much change, but as we go starting from 2020 we can see that the central portfolio started to take off faster and influencing all the market, and we can see the peripheral portfolio is behind and start taking off maybe like February 2021. If we go to later periods, we can see the difference is getting bigger. You can see the central portfolio went up 830%, while the peripheral portfolio only went up by 240. Even till the end of 2022, we can see that even the market is down. We can see that the central portfolio is still at 139%, while the peripheral portfolio is in the negative now. So now let's just add legends for the different cryptos in each of the portfolios. For that, from visual, we'll just use a simple matrix and feed to it the crypto name and the portfolio name in the rows. Let's just rename this so we don't see headers to dot, for example. Let's expand this, format it. From style, we select none, and from general, we remove the background. So now we have the cryptocurrencies for each of the portfolios. And this concludes the first part of this project. So in this part, we performed networks analysis for some of the cryptocurrencies over the last 4.5 years. And it was evident that the generated central portfolio led the movement of the rest of the cryptocurrencies we had in this study. If you found the content of this episode valuable, please hit the like button and leave comments with your thoughts. If you're new, make sure to subscribe to this channel. You don't want to miss the next part. In the next part of this project, we'll put our discoveries today to test for the data of year 2023. Also, we'll develop the Power BI dashboard further to become a tool to help you plan your cryptocurrencies investments. So stay tuned for the next part of this project. Peace.